Hi everyone. In this video, we are going to start our final project. For our final project, we are going to create a basic voting app where we can vote, approve, reject, or pass for a proposal. We are going to store these proposals so that we can iterate over them. So let's get started with our basic structure setup. As you can see, I created some imports here, and also I created our memory like we did in our previous chapter. And we also have the max value size. So this is just a basic setup that we are going to use in many cases. So I just went over it and created for us so that we can start our coding right away. For our project, we are going to have two structs. The first struct is going to have our data for the proposal, and the second struct will be provided for our functions so that we can create our proposals and edit them. We don't need all the fields for our first struct. We have a separate struct just for function parameters. So I'm going to start my struct with our derive. Don't forget, since we are going to need these to implement in the candidate file, we are going to say these are candidate type. And by saying these are candidate type, what I mean by these are our structs. We are saying that we are going to convert this to a version that can be used in the candidate file. Also, we are going to import this serialized. Okay. Our struct's name will be proposal. And we are going to have a couple of fields. First, we will have our description, and it will be a string. Next, we have approve, which is U32. This approve means the number of approves we have in our proposal. Instead of saying number of approves or number of rejects every time, I'm just saying approve. But if we have 5 as a value in the approve, it means that we got approved 5 times. So we are just holding these numbers as the counters. Next, we are going to have reject, which is also going to be U32. And finally, we have pass. So these will be the 3 options that we are going to have. And then we are going to have more data about our proposal. First, we have is active. We have this is active because we may have some proposals, but since their time has passed or the creator just stopped it, we cannot vote on it anymore. So to hold this value to decide when we can vote or not, we are going to have this is active, and it's going to be a type of Boolean. We are going to have different principles stored here, and these are the people who voted already for this proposal so that one person can just vote one time. And we will be saying a vector, and it will be principal from the candidate type. And finally, we have the owner, and this will be the owner of this proposal. Again, this will be principal. All right, this will be our basic structure. We have an error here. Let's check it out. All right, in our corgo.toml file, we need to add this serde so that it can work with it. Now everything looks okay, and we are going to create our second struct, which will be create proposal, and we are going to use this as an input for our edit and create proposal functions. Again, I'm going to say derive candidate type and deserialize. And inside this struct, we will have the description, which will be type of string, and we are going to have is active. We just need 2 different fields here because we are going to initialize approve, reject, pass with zeros, and also when we want to edit, we cannot edit approve, then it would be not reliable. And also the people who have voted cannot be changed, or we are not going to initialize this with something. So we are not going to touch these fields, and also the owner will come from the message. We are not going to type who is the owner. So we don't need to give these fields as a parameter. We just need to give description and is active. Now that we have created our structs, let's implement our traits for these structs like we did before. First, we are going to say implement storable for proposal. And we are going to say 2 bytes to serialize it. And inside this, we are going to say cow owned encode. And inside this, we are going to provide self.unwrap. If you cannot do this by just memory, don't worry about it. It's going to take some time, but as you can see, we did this before. and it's a pretty straightforward process. So after a while, you get used to it. As you can see, we have an error here, and the error says that not all trait items implemented missing from bytes. We created the 2 bytes, but we also need to create from bytes because that's what we need for the storable trait. Now let's say from bytes, and inside this from bytes, we are going to decode what we have, and we will say bytes dot as reference, and we are going to have self as a second parameter, and finally unwrap. Again, at this point, you don't have to know what every function and every bit does in this trait implementation, but what we need to know is that with this 2 bytes function, we are actually serializing our data to bytes to store on the stable memory, and then we are deserializing back so that we can have our variable back. As you can see here, we have a return type as self because we are decoding and getting back the data. This is necessary for our serialization and deserialization process, for our upgrades, and that's why we also said deserialize here. Now we are going to implement bound.storable for proposal. We are going to say to our construct that how we are going to bound this structure that we are creating. We will say the max size will be max value size value that we have here, and also we are going to say is fixed size, and then we will say false because it can grow and shrink, and that's why we are creating this structure. Now we have our 2 structs that we are going to use. We said that we are going to use this for our main structure for our state, and we also have a separate one so that we can use with our functions as parameter. And then we implemented Storable so that we can serialize and deserialize our proposal struct here. And then we implemented this bounded storable so that computer knows what are the limits of our structure. Now the last thing that I want to do for our state management part of this contract, we are going to create our thread local, and we are going to implement our memory. I will say thread local here, and inside this we are going to create our memory manager like we did before. If you remember, we have just one memory that we can work with here, but we want to have a structure that can work with different kind of memories. We need to have multiple memories. So instead of having this physically, we are creating this structure virtually. And for this, we are using memory manager. And since we are going to have 256 virtual places that we can use as memory locations, we are going to say this one is for the 0 index, this one is for the first index. Using the structure like this, we can have multiple memory locations. I'm going to create my memory manager by saying memory manager, and its type is going to be RefCell because we want to borrow what we are going to create as mutable or immutable, and we will say memory manager, and inside the memory manager we will have default memory implementation. So this will be the type that is going to return to us, and what we are going to say here is that RefCell new memory manager, and we are initializing our memory manager. We are initializing it with default memory implementation, and let's call the function default. Alright, again, I know it looks like too much, but once you know what you want to do and once you know how it works, after a couple of implementations, it's going to feel much more natural than it's feeling right now. Again, we are creating this memory manager using RefCell, and we are calling new function from this RefCell. We are going to do this for our other maps that we are going to use. And we are initializing our memory manager with this default memory implementation. Now let's create a proposal map that is going to hold our proposals. For that, I'm going to say static proposal map, and its type is going to be RefCell stable BTreeMap. We are going to have U64 as the key, but we are going to have proposals as the value, and we are going to use our memory. Again, we will say RefCell, and we are going to call the new function, and inside this new function we are going to say stable B3 map init. As you can see, we are doing a very similar thing like we did before. We are creating this RefCell with the new function, and we are initializing our stable BTreeMap. Before we were initializing our memory manager, so we were saying memory manager init. Now, since we are initializing our bstable tree map, we are saying bstable tree map init. So even though there are differences, we can see that the basic idea and structure is the same. And inside this init, we are going to say, let's make it like this, memory manager dot with, because we want to create our memory inside this memory manager so that we can have multiple memory locations if we need them. And let's say m here. So we are going to borrow this m, and we are going to say get memory id new 0. So it's exactly how we did on the last chapter. Alright, so this will be the structure for our smart contract. So let's review what we did in this lesson. We created two different structs, one to store our data and one to use as parameter. Then we said that, okay, we created the struct, but this struct needs to implement some traits so that we can deserialize and serialize it. So for this process, we said we are going to implement this storable trait. And inside this trait, we had 2 bytes and from bytes functions. And if you forget one, as we saw earlier, Rust is going to complain. You cannot just miss it or skip it. You will have to fix it, and it's going to tell you that one function is missing. And then we said, okay, now we can serialize and deserialize it, but what are the limits? The computer doesn't know it. For that, we created our limits using the bounded storable trait. And inside this trait, we have our max size and isFix size. For our max size, we use our max value size that we defined in the beginning of the contract. Next, after everything is ready, we said that we are going to actually create our memory location so we can use this structure that we created. For that, we said first we need to create this memory manager so that we can have multiple virtual memories. And after we created this memory manager, we created our proposal map, and we use this memory manager to handle our memory locations. And we use the first memory location with the index 0 for this. Alright, thank you for watching this video. Again, as you can see, we are doing a similar process like we did before, so there is nothing to worry about. And in the next lesson, we are going to start implementing our functions so that we can see how our contract is going to work. Thank you very much for this video, and I will see you on the next one.